Let's look at the atomic structure. What are we talking about? What we're talking about in atomic structure is what do we think these atoms look like? How are they arranged? What are they made up of? And what we think they're made up of are these things called subatomic particles. And so each atom or element on the periodic table is determined by how many of the subatomic particles it has. The first subatomic particle that we'll talk about is a proton. You can see here in this figure in A and B, the protons are labeled as the pink dots. Protons carry a positive charge and they weigh something called an atomic mass unit. The yellow dots are indicative of neutrons. So neutrons are hanging out with the protons and they have no net electrical charge, so they're neutral. And they also are thought to weigh 1 atomic mass unit. Then you might see or notice these rings outside of these pink and yellow dots, and they have little blue dots on them. These little blue dots are known as electrons. And electrons have a negative charge. They're so tiny that they are considered to have a very negligible weight, so we don't count it. But this section here in the middle where you see the protons and the neutrons is called the nucleus. So you're going to find your protons and your neutrons together in the nucleus. Additionally, the number of protons in any given atom is generally the same as the number of electrons. And there are some exceptions which you might notice in the simulation. So here in A, we have carbon. It's got 6 protons and 6 neutrons. It also has 6 electrons. Sodium, however, in B has 11 protons and 11 electrons, so it's neutral. It doesn't have a net charge, but notice it has 12 neutrons. All right, so those are some of the differences. The way that A and B are drawn out, this model is called a planetary model. There are several suggestions for how we might model or how these subatomic particles exist, but these 2 models here, or these drawings in A and B, are planetary. Down here in C, this model is called the orbital model, and you'll see the electrons are drawn as if they're making a cloud around the nucleus. All right, so your nucleus has your protons and your neutrons, and the electrons exist spinning around the nucleus. How do we identify elements? Basically, as I said in the previous slide, atoms of different elements contain different numbers of subatomic particles, and this is how we differentiate them. So here, for example, you can see in the figure, we have hydrogen that has 1 proton and 1 electron. So it's neutral because the positive charge and a negative charge cancels each other out, but it has no neutrons. When you add a proton and an electron, but then also add 2 neutrons, you get helium. Lithium is composed of 3 protons and 3 electrons and 4 neutrons. Atomic symbols and what all of these things mean. Essentially, again, that mass number, because the protons and the neutrons have 1 atomic mass unit of weight, or 1 atomic mass. Then we add the protons and the neutrons, and that will give us the total mass number. The atomic number then is going to give us the number of electrons and protons. So in carbon here, you can see there's 6 electrons and 6 protons. So that's individually how many electrons and protons.